All right, so here's our agenda for today. We're going to wrap up as much of the set section from 4.1 as possible. One thing I want you to be aware of is, have you noticed how like the first 2 pages of this was a lot of discussion and trying to understand or wrap our minds around this idea of equations and things like that? And then the ready and the go section that I've been having you do with homework is just practice with specific skills. And then the set section is supposed to help us set in or like finalize the ideas that we've been discussing about. That's how this practice is designed, okay? So remember, this is only the first lesson. You're not supposed to be experts in it yet. We're going to develop our understanding as we move along for a good bit. After we do the set section from 4.1, we're going to go over this vocabulary, which means we probably won't get to 4.2 today. That was apparently very ambitious of me, and that's okay. So the objectives that we have with this set section, which just as a heads up, the set section is the very last part of the packet. So okay, go ahead and flip all the way to the back. We want to be able to determine if 2 different expressions are equivalent. That is the first thing that we're going to do. The second thing is we're going to use inverse operations and the properties of equality in the most efficient path to solve an equation. We're going to talk about some alternative ways we can solve them as well with the idea of equivalent expressions as well. But this is our objectives. Hopefully we recognize a few of those words, right?
Yes.
There we go. It only took 3 or 4 seconds, but someone eventually said something. All right, so here's where we're starting. This is the set section. One thing I do want you to be aware of, first off, the bold always is your directions. Secondly, there's a topic. If you Google the topic, whenever you're working on something at home, this is on the ready section, the set section, and the go section, there are different topics. If you Google this topic, there will be information that pops up very quickly on Google that can help you with answering these questions. So this is one of the reasons why I really like what's called an MVP, Mathematics Vision Project, because they have actually researched all these things to make sure that you have something that can help you. Now at the same time, every day I'm recording. I'm usually recording in 5th period, but I didn't do that today. I'm recording with y'all today, okay? But you can actually find a link on Schoology to every YouTube video that I've made for this class. And I put the dates on there, I put whatever the task was, all that stuff to help you get the resources you need to be successful. Okay? We all good with that? Any questions about that? I'll take that silence as a no. Fantastic. Alright, so number 7 and the rest of these 4 right here, determine if 2 expressions listed are equivalent. And explain your reasoning. When I look at, say, 14 minus 3, actually let's come back to that one. Let's do 8 instead. We'll do 8 and 9. If I'm looking at 4b minus 10 and 2 times 2b minus 5, how can I determine if those things are equivalent? What does that mean?
Equal.
Partially, okay? Remember, we talked about equivalent equations over the last few days as well. What did we mean by equivalent equivalents?
They have the same solution?
They had the same solution. Did they always look the same?
No.
No, but they were effectively the same?
Yeah.
Equivalent means the same, but they may look different, right? So we want to know, hey, are these 2 expressions effectively the same? They just look different? Does anyone have a way or a guess how I could determine if those 2 things are effectively the same?
Reverse no, whatever.
What do you say? Okay, so let's talk about that term solve. Whenever we say solve, that is the process to find a solution. And there's lots of different processes to find a solution, but what do I mean by a solution?
The answer.
But what is the answer?
The value that make the equation true.
Please understand, that's something we've talked about heavily. A solution only has one definition. It is the value that makes an equation true. Do we have an equation here?
Yeah.
You sure? It literally says that it's expressions. It doesn't call them equations. What makes something an expression and not an equation?
When there's no equal sign.
There's not an equal sign, right? If it said equals 5, that's an equation. That's something I can solve. And please hear me very clearly on this, because I know that you've had teachers in the past who have used the word solve for everything. But solve only means this. And this is why we need to work on our vocabulary. This is why I give you those vocab sheets, so that we can be intentional about understanding what terms mean. A solve literally is only the process to find a solution, and a solution is only the value that makes the equation true. Which you can have two variables, which means you need two different values to make the equation true, but we don't have this here. So can I solve these expressions? Does that make sense? Great guess, and this is why I like y'all to make guesses. By making that guess, were we able to come to a better understanding of what different terms mean? When we make mistakes, mistakes are opportunities to learn. You just got to be willing to take a chance, make a guess, something like that. Okay, so let's continue thinking. How could I determine if these two things are equivalent?
Inverse operation. Well,
Now-
interval notation.
Okay, so if we use inverses, though, inverses is part of the process of solving, right? Because whatever I do to one side, I have to do to the other. That's the properties of equality. But equality, again, deals with an equation. So can I use inverses here? Okay, let me ask you this. If I let b equal 5, and I plug it into both of these, if these are equivalent, and I plug in a 5, what should happen?
They should have the same answer.
They should have the same thing, right? Let's test it out. So 4 times 5 minus 10. And 2 times 5 minus 5. We're trying to see if those two things are the same. So what do I need to do to figure that out? Multiply. So what is 4 times 5? 20 minus 10? What do I need to do over here first? 2 times 5 is 10. 10 minus 5? 2 times 5? So are they the same? Now that's pretty good evidence that they're equivalent, right? However, I want to point this out. Have I proven that they're equivalent for every number that I could plug into B? No, I've only proven it for what number? 5. So to prove it for every number, I need to check other numbers, right? What's another number you want to check? Okay, let's check 7. What's 4 times 7? 4 times 7? Remember guys, we also have calculators in the back of the room. Zay, can you go grab calculators for your group? Trey, can you go grab a calculator for yourself? 4 times 7.
Oh, 28.
28. What's 28 minus 10? 18. Okay, let's start over here. What's 2 times 7? 14. 14 minus 5? Close. It'd be 16 minus 5 would be 11. Thank you, Zay.
9.
9. 14 minus 4 would be 10, right? So we're 1 past that, so 9. So what's 2 times 9?
18.
18. So are they the same?
Yes.
Now, have I proven it to be true for every number for B, though?
No.
Does anyone see a problem that we're running into?
You don't have a table?
Not just that I don't have a table.
It's impossible
What do you mean it's impossible?
to put every number in.
Why do you say it's impossible to plug every number in for B?
It's a lot of numbers.
There's a lot of numbers. Do you know how many numbers there are?
10.
Huh? Just not 20.
Infinity.
Infinitely many, right? First off, all the numbers can go to infinity. Second off, aren't there a whole bunch of decimals?
Yes.
Aren't there even negative numbers?
Yes.
So can we plug every number in?
No.
No, that would be impossible, right? Okay, so we don't want to plug every number in. But I want you to notice, after we plug numbers in, what process did we follow? We took a more complex expression and made it simpler. So what are we doing?
Simplification.
We were simplifying, right? Now, can I simplify 4b minus 10? Is there anything I can do there? What can you
No.
combine, CJ? Okay, but we are multiplying, but do you know what 4 times b actually is? Can I simplify that?
Can I see who called me? Probably my uncle. He probably bring me sometime. I need something to get that.
Check it quickly. So notice I can't do 4 times b. I can't subtract 10 from it either. Alright, so when I look right here though, is there anything I could do to simplify this expression?
Take it off.
Multiply 2
B.
with the
I would like to get my own shirt. My,
Be quick. So you see how that 2 is outside the parentheses? Go quickly.
no,
I got the 2 in the parentheses, so what process can I follow here?
distribution.
Distribution is what it's called, distributive property. What's 2 times 2b?
4b,
4b. What's 2 times negative 5?
10.
Close. Negative 5.
Negative 10.
Negative 10. Are those the same thing?
Yes.
They're literally identical to each other, so are they equivalent?
Yes.
Have I proven it now for any value for b? Yes. They're always going to be the same. So I need you to notice. We can plug some numbers in, but are you ever going to be able to plug in enough numbers?
Nope.
Nope. But can you simplify it and see if they become the same?
Yeah.
Yeah. So they're equivalent because the expressions became the same while simplifying. Say again? Well, we need to justify, right? It even says explain your reasoning. We need to get in that practice of justifying, right? Because that's a big part of your quizzes and of your test. Okay? By the way, before I get too far ahead, please go ahead and put a minus here between that W and 9. For some reason it didn't print. Okay. So let's talk about number 9. Does anyone see a way that we could simplify number 9 to see if they are equivalent? What do you mean by divide it? Press on that a little bit more. I'm not disagreeing with you, but I'm curious how you mean that.
Divide the 7.
By what? By the 4? But do I know what x divided by 4 would be? Now, CJ, are you talking about this first expression or are you talking about the second expression? The first one? So let me ask y'all, can I do x divided by 4 minus 7 divided by 4? You don't think so? You can? Why do you think so?
Did you know what the X is?
You don't know what the x is, but let's go a little bit beyond that.
Plug some number.
Say again.
You can plug a number in.
You could plug a number in to check, but I want you to notice right here. When we were multiplying, what property did we use?
Distribute.
The distributive property, right? Now, aren't multiplication and division pretty similar to each other? In fact, like 8 divided by 4, isn't that the same thing as 8 times 1 divided by 4? So if I can distribute with multiplication, do you think I can distribute with division?
Yeah.
So I distributed my division to both of these things. X divided by 4 and 7 divided by 4. Do you think that's legal?
Yeah.
It actually is, right? Like, distribution is something that works with multiplication, so it also works with division. Here's another way to understand it a little bit. Okay? Actually, go ahead and write that note, and then I'll show you how another way to understand it. Okay. So one thing I want you to notice here x minus 7 divided by 4, that would be the same thing as 1 divided by 4 times x minus 7. Is that true? At least if I put that inside parentheses. Is that a true statement?
Oh, you.
Yeah. Notice if this is over 1, what's 1 times x minus 7? X minus 7? What's 4 times 1? So is this the same thing as that? Are they the same? Yeah. So I want you to notice, I'm multiplying now so I can distribute. X times 1 will be x, and then divided by 4. Negative 7 times 1 will be negative 7, then divided by 4. So that division can definitively be distributed. Are they equivalent? We go with those ideas? Okay. While Zay is not with us, I want all three of you, never mind, Zay's back. I want you in your groups to look at numbers 7 and 10 and try to figure out if those are equivalent.
Appreciate it.
Yes, sir. So look at 7 and 10. I want y'all to take about 3 or 4 minutes and talk amongst your groups yourselves. Are those equivalent?